afternoon. Welcome back to stage. This will be the last but not least presentation of the Design for Life event of Dassault Systèmes at the Design Week in Milano. And it is my pleasure to introduce this team for several reasons. First of all, because the theme of the day is social forward. And these kids come from high school. So there is no more future than this. And forward because they are specializing and working very hard in creating a transportation that is more affordable, is more sustainable, is more efficient. So in a word, what the testimony that you will see today is really the paradigm of social forward that we are discussing today. Secondly, this team is particularly dear to me because they come from a high school that is very close in a city, in a town, Carpi, that is very close to my original hometown, which is Modena. So they will tell you a fantastic story. This team participated to the Eco Shell Marathon, which is a worldwide competition in several categories, and they focus on the electric vehicle categories. In 2017, this team won this worldwide competition in London. They beat 30 teams with the prowess of their technology, their thinking, their teamwork, that I think is an example for everybody, as is absolutely amazing. And you will see the passion and the competence of this team that is truly starting. So it is my honor to pass the microphone to the leader of this team, Professor Franco Bonaccini, who will introduce the team and will start the conversation of today.
Good afternoon. My name is Franco Bonaccini. I am a technical teacher in ITIS Leonardo da Vinci, Technical Institute in Carpi. Here are some components of Eco Marathon team, especially.
I'm Matteo Tarabini, the team manager for this season of Team 0C.
Good afternoon, I'm Enrico Briganelli and I take care of the stop of the car.
Good afternoon everyone, I'm Emanuele Marconi, I'm the mechanical designer of the team.
Okay, we are here to talk about something different than normal activity of design made in school using SolidWorks, but today we will speak about something different, especially we will talk about Shell Eco Marathon project.
Yes, well, the whole history started back in 2007 when two professors and a few students decided to build a vehicle to take part in Shell Eco Marathon, which is this international competition that challenges schools all around the globe to build energy-efficient vehicles and then drive them to obtain a best result. So we chose the name Team 0C to point out the environmental purpose of the activity, which is zero carbon emissions, so a clean mobility. And in fact, the winner of this race is not the fastest, but is the most efficient. So, as you know, pollution in our country and in the world is increasing, and that's a big problem. And especially in our area, the Po Valley, we have this problem of air stagnation. So the air basically remains in the area and it creates pollution, you know. And sometimes the CO2 concentration in the air can rise up to 410 parts per million, which is quite high. So in doing our project, we believe that we can have a positive impact on who is watching us, who is following us, and we want to prove that in the middle of this industrial area, there is still someone that cares about environmental awareness. So going back to the very origin of the activity, we have 1 year, 1985. This year is important because it was the very first edition of Shell Eco Marathon, so it's quite old. It was held in France at Circuit Paul Ricard. And an interesting fact about this this picture is that some of the participants that you see on the grid that year are still competing and someone still winning this year. So in that respect, we are quite young, I would say. Coming back to the present, nowadays, after 35 years of competition, we have grown to become more than 700 teams all around the world. Also because Shell Eco Marathon has spread in every continent and has divided in 3 main competitions, one in Asia, one in Europe, and one in the Americas. And so we can say that we are a big family. So first, before talking about the project itself, we thought it was better to understand the very nature of the challenge. So the competition is basically divided into 2 main categories. We have the urban concepts, which are quite similar to the real road cars we see in our cities. And we have the prototypes, which are quite more extreme. These 2 categories are then furtherly divided based on their power source. So they could be powered by standard internal combustion engines or battery electric or even hydrogen fuel cell. So there are many new technologies that can be experimented in this competition. Well, we chose to build and then to drive in the competition a prototype in the battery electric category because we think it's one of the key elements for the future.
And as a battery electric, we have to complete 14.5 kilometers in a maximum time given of 35 minutes. Intuitively, the fastest you go, the more energy you use. On the other hand, if we go too slow, we risk to get over the time limit and be therefore disqualified. So the perfect strategy is the one that brings the vehicle the closest possible to the time limit. And in doing this, a Joule meter, a device that measures the energy consumption in Joule, is attached to our electronic. And at the end of every attempt, a marshal reads the result on this device. 2 years ago, we made our record after a tough battle with the Spanish team, and this record is 753 kilometers per kilowatt hour. That in liter is 7,500 kilometers per liter. That's an incredible result. But the way was very long to reach the top of this competition, from barely achieving a real attempt to the top, to the first place. And another difficult point is to retain the first place. In fact, last year we dropped back at the 3rd place, but we are working very hard this year to be back to the 1st place. So, when we decided to design a new car 2 years ago, we had to keep in mind 3 particular preconditions: the driver, the rules, and the energy optimization. First of all, we had to respect the rules on the official rules book by Shell, and then we had to fit the drivers in the car. That's, we can say, tailor-made for our driver. And last but not least, the energy optimization by reducing the CX or the frontal area and the weight. In order to reduce the CX and also the frontal area, we took inspiration from the aerodynamics sector, using the NACA airfoil profile, mostly used in the aerospace industry. In particular, we used neutral NACA airfoil in order to have the smoothest riding possible, and here SolidWorks enter in the game.
In fact, now we are getting into the details of the design process of our prototype on SolidWorks. And as you will see, the whole procedure is quite simple to understand, but for arriving at this level, we have made our many shape, many prototype, and we have studied them. So let's start to the video. And the next step, the first step is to create a loft between two profiles, a NACA profile on the side and a spline on the top. In fact, you can see that the high spot is in the middle of the car for a safety reason. Then we replicate the same feature on the bottom to avoid the well-known ground effect. And we are able to mirror this feature to create our water drop shape. That is the central part of our prototype. And then moving to the rear side, we create our rear wheel case, started from a NACA profile neutral. And then we're moving to the frontal area of our prototype. And as you can see, the cases are stretched and extended for be able to steer our wheel. And in fact, our prototype have the frontal wheel as a steering wheel. And at the finish, we finish our prototype with some fillets around the prototype to have a better airflow around our profile. And after having completed our bodywork shape, we moving on a CFD analysis tools of SolidWorks, well known as flow simulation. And 2 years ago, with this tool, we have achieved our best results of 0.108 of CX coefficient. And here, SolidWorks cover a very important mention. In fact, every year we can improve our knowledge, our abilities, and our efficiency in this field. Moving to a less technical topic, a new challenge is the title of this slide. In fact, this year the Shell Ego Marathon Europe will be held in Brooklyn, near a city nearby London. A historical circuit built back in 1907 by an English businessman who wants to improve sports car performances and sports car efficiency. And it's interesting to thinking that after more than a century, it is used for the same purpose once again.
This project is the perfect combination with the spirit of our school. In fact, we believe that our students can learn better by applying theory and, when it's possible, adding more technical contents from hands-on experience. The whole construction process is performed inside the school by students, sometimes supported by business partners that provide the knowledge from the professional world. Alongside the technical education, there are also a few personal soft skills that are acquired by the students. For example, they get to collaborate and organize their work as a team, where everyone has precise roles and tasks, and which is quite motivating. They work for a common objective. Finally, they share a life experience that will be hardly forgotten.
And we can just agree with our professor. And concluding, we have a video for you that sums up pretty much all the things we've said. And you can also see some motions of our vehicle, some images from the race. So enjoy.
I am Stefano Covezzi. I teach mechanics in this institute and I am the coordinator of the Eco Marathon project. The realization of our vehicle starts in this workshop. The real improvement for us is to use SolidWorks.
I'm a member of this school and the team manager of Team 0C. We compete with our school-built electric prototype in Shell Eco Marathon, an international race that challenges schools around the globe to design, build and drive the most energy-efficient vehicles. This activity is a real opportunity for us to practice all the notions we've learned in school courses.
In our team, we make sure that everyone knows the tasks required to design a component. So are here, we set up a design course for rookies to learn the basics of drawing in order to prepare them to work more independently. For me, it was really helpful to begin understanding what's going on inside the car and how I could improve the already existing parts.
From a student point of view, SolidWorks represents a great opportunity to step in the world of design. It's user-friendly, although it has lots of advanced features that make it an highly valuable mechanical, engineering and educational software.
Our competition is one of a kind. We always remember that the winner is not the fastest, but the most energy efficient. So, we want our vehicle to be the smallest, lightest and smoothest running possible.
We defined the shape of the car thanks to the CFD feature in SolidWorks. We started from an initial concept shape that was optimized to find the best fit around the driver's body and at the same time to minimize the aerodynamic drag, which is one of the factors that make us lose energy.
We always have to keep in mind that as far as it may seem to go slow, it's still a race car, so it has to be stiff and solid enough to withstand the forces that act on the structure during the race. So we took advantage from SolidWorks FEM analysis tools, we simulated our working condition and we made sure everything was correctly shaped and fully operational.
It's really gratifying for us to see how the students are able to design and virtually test many parts of the project.
We are constantly raising the bar of innovation, pushing forward to a continuous improvement both on personal and professional side, because we are competing against the best universities in the world and we eventually won in 2017. We have the strongest motivation, the best tools for design and the maximum support from our sponsors, especially from Nova Makut. There's nothing more we could ask for.
As a wannabe engineer, I know for sure that in my future I will have to work with some kind of 3D modeling tools, and I know that I'm prepared for that.
So thank you very much. I think you all noticed the articulation, the competence that exudes from this team. I think it's very, this presentation was very interesting and also very encouraging for all of us in the technology since many years, seeing these young students, very accomplished technologists coming forward and focusing on solving these very, very difficult problems. So, I've seen that you called this car a specific name, right? You didn't tell us. It is Scorpio?
Yeah.
Where does it come from?
Yeah, actually, Scorpio was the name of an invention of Leonardo da Vinci, the man who has named after our school. And it was basically in ships, in warships, it was a sort of weapon that was used to sink the other ships. So, of course, we are not intending to sink the other vehicles during the race, but as it's a quite innovative invention, we took that name for our vehicle because it's very innovative, like the invention of Leonardo da Vinci.
So at the end it was a competition, so you did want to sink your adversaries. Let's tell the truth, let's tell the truth.
Not too much.
just enough to win, as you
Yeah.
did, right? Okay, good. So speaking of which, there were 30 teams competing in London in 2017. what was your relationship with the other teams? How was the dynamics and the connections during the competition? Did you build friendship beyond the competition itself, or how did it work?
I think it's a great event to relate with other teams because everyone is coming from a different country. You know, everyone is adopting different solutions. So we have, as we said in the presentation, we have these two sides: technical side and relationship side, and they are both very, very important. We became friends with our fierce opponent that won this year. We are still friends. And furthermore, the whole spirit of the competition, we can say that it encourages us to share, to build relationships with the others. So in this respect, it's quite good for us to participate in that.
Okay. So you have shown very technical details here, and I would like to comment. I'm an engineer myself, so those things are very interesting. You speak of a coefficient of drag of 0.1, but it's pretty amazing. I think the average, what is for commercial vehicles, like 0.3, what is the average? 0.3? Can you comment on that?
It's amazing, and for arriving at this level, we need many years. In fact, we started in 2007, and with the SolidWorks and analysis, a study of our bodywork, we can arrive at this level. And every year we're improving our coefficient, our CX, and maybe in the next prototype, in the next our vehicle, the CX could be lower than it.
Yeah, maybe compared to this car, the first one that we built in 2007 was like a truck. Yeah, it was around, let me remember, around 0.25. So it was completely another world. It's very, very rewarding.
So this is a very advanced science. It's computational fluid dynamics, right? So, Professor, you teach these things at high school kids?
Yes, we try to teach this kind of study and of project with our guides, because we think, or I think, that is really important, and it's nearly the future. The simulation in the mechanical project is now an element that is not possible be without it. So we believe, and we get good results, we think.
Still staying on this CFD topic, so did you modify your shape to improve the CX computation? And was the tool good enough to tell you where were the areas to improve the best? And was parametric design a good technology to achieve optimal drag reduction?
We changed our form, not in a big changes, but in small details, like frontal area, as small as possible, but always the driver maybe must be in the vehicle. So our main dimension are the driver, and also we modify the wheel cases, and we realize them as smooth as possible, and like this we can improve our coefficient.
For example, we with the old prototypes had a track rate very, very low, and with the time we studied it, and we noticed that an higher height from the road avoid this ground effect. That's an enemy for us.
So how important is the technology of the wheels for achieving this type of efficiency? Did you use special type of rubbers? So how did you choose those things?
Some studies have proved that the efficiency of a road vehicle is based more than half of it on the rubber. So we have special tires produced by Michelin purposely for this competition, and they are like 10 times more efficient than the more efficient on the market. So it's something very innovative as technology, and we are glad to use this technology to innovate even more. So yeah, we use this particular type of wheel.
So this team is engaging with companies of the size of Michelin, having a conversation on this type of things. And this is high school students, guys. This is, we are building an amazing future. I have a question for Professor Bonaccini. Actually, two questions. One, so this is a very bright example of engineering education in high school in Italy. I think it's probably the top of the possibilities. So the first question is about the status of engineering and science in education in general. The other question is, what is the role of young women in STEM, in science, technology, engineering and mathematics? There was a young woman that participated to the video. We saw many of them participating in the competition. So we would like to have more women participation in this type of thing. What is the state? What is your feeling? Tell us about that.
Concerning the eco-marathon team, there are good examples of girls in the team. One is also a driver, and yes, and another one works with the colleagues like normal way. And we would like to have more girls, but it's not so easy for mechanical. At the moment, has not so great attraction. There is more attraction for info technology, informatic, I think, data technology, and electronic technology. In this course, we have more female presence. Sometimes we have girls also in mechanical, but are not so great. 2 or 3 every 2 years, more or less. These are the numbers, not so high. And the first question was about...
It was about your opinion of the status of technology education in Italy at the high school level, which is a fundamental level.
This is a special field because we have to follow some guidelines from national indication, but for this kind of project is very important also how is the interest and the inclination of the teachers and the motivation of the teacher in the way to motivate again the guys in the way to go on with this kind of project.
So motivation is an important factor. So to achieve excellence. So to close, I would like to ask a question to each of the students. Each of you, please tell us what is your plan for the future. What do you want to do in your life?
Shall I start?
That's a tough question. I admit it's a tough question.
Yeah.
I still ask myself this question, trust me.
I've thought about it, and I think this project maybe gave me a little help on this decision. And since I was born, I'm interested in racing cars, in motorsport, and because of this project, even in innovation. So I'm planning on starting my studies of vehicle engineering in Modena. Yeah, let's see how it goes.
Following his opinion, also me, I am going to try a university, automotive engineering university, in order to obtain a role or something in automotive race. track race or also off-road race. And I think that since I was a child, the 4 wheels are in my heart.
Maybe 3 wheels.
But we only have 3.
Maybe 3.
Our Scorpio has 3 wheels.
Little compromise.
I lost one on the road.
I like more the aerodynamic aspect of our prototype and aerodynamic aspect in race car and sports car in general. And I think that next year I will go to aerospace engineering in Forlì, and I'm a lot excited for that.
Very good. So I think you guys have a bright career in front of you, and I would like to extend a special thank to your professor, because at the end of the story, we need people like this that inspire students, inspire young people, and give you the tools and the intellectual ability to pursue your dreams. So a big applause. Good.
Yeah, and I would like to say thank you also to you and to all the companies, the business partners that make this possible, because without them, without you, we wouldn't be here. So yeah, a big round of applause for us, but even for you. So thank you.
Thank you very much. But again, the teachers really make a difference. So a big applause. Thank you very much.
Thank you.